What we're going to go over today, guys, is we're going to look at graphing. Okay, just kind of going to talk about why graphing is important in science. And then we're going to look at how do we make proper line graphs, because that's usually what we make in science is line graphs using Google Sheets, because we're going to have to do that for our lab that we're going to do, okay, and well, actually for a number of labs that we'll do. And then, of course, going forward in all of the sciences, you have to build graphs all the time. Okay, graphs are an important scientific tool, so it's important for us to know how we construct those and how we put the information on that we need. And then we're going to look at how do we calculate information from the graph that may or may not be on the graph? Okay, so we'll look at using the graphing equation, that's y equals mx plus b, okay, to answer problems and things like that. All right, so we'll start off first off with graphs. Okay, basic structure of a graph. A graph has an x-axis and a y-axis. Which one's the horizontal one? X. Okay, so x is the horizontal axis. Okay, so we can label that. Okay, this is always going to be the horizontal axis. Y is the vertical axis, right? Other important things, and this is actually in your notes package as well, but in a different format, it looks different. Okay, the x-axis is where the manipulated variable goes. Okay, the y-axis is where the responding variable goes. That way, we can see what happens to the responding variable as the manipulated variable is changed. Okay, most of the time increased, okay, but that's not always fixed. All right, so what we see here on this graph, okay, is a graph that's pretty good, but's missing one thing. What does it not have? It doesn't have a title. All graphs need a title. Okay, nice thing about Google Sheets is it automatically puts those on for you as long as you tell it what it wants it to be. Otherwise, it picks some ridiculous thing. Okay, sometimes it doesn't make any sense, but it always puts a title on there. Okay, you just need to make it the right kind of title. So I would say this could be like temperature versus photosynthesis. Right, that's kind of a bland title, but okay, that's what's on this graph. Okay, so people would understand when they look at it. Otherwise, just looking at a graph, it could be a graph of lots of things. Okay, what's helpful is that the person has at least labeled both the x and y axis, so I know what's on here. Okay, this graph is telling me the relationship between temperature on the x-axis and the rate of photosynthesis. And because I know the x-axis is the manipulated variable, I can at least get an idea of how this experiment that this person ran went, right? What I did was this person, when they ran the experiment, was they essentially had plants at different temperatures and recorded probably like the amount of carbon dioxide or oxygen, carbon dioxide that was used or oxygen that was produced by a plant in an enclosed environment. Okay, that would be a way to track the rate of photosynthesis, right? So they would have had several different plants and they would have tracked essentially how much gas was exchanged or something like that as a measure of the rate of photosynthesis. Okay, and I can see from their graph that the general trend is that as temperature increases, the rate of photosynthesis also increases until till about 32, something like that, around 30 degrees, it kind of starts to plateau, and then after that, it just plummets. Okay. Now, would that be true for all plants? Probably not. I mean, if you were in a tropical rainforest, it's going to be 30 degrees or more all the time, so you'd have to be able to tolerate that. But for this particular plant anyway, they don't mention which it is. That might be something in the title they could have included. We can at least assume that this is a plant that functions pretty well around 25 degrees. All right, that's what we can learn from this graph. It's a quick visual representation of an experiment. Okay, rather than having to read through all of their entire experiment and their abstract and all that other stuff, okay, I can look at this graph and get a general idea of what they were doing. Okay, that's why graphs are useful. Okay, they give me a very quick visual summary of the results of that particular experiment. Now, obviously, I'm doing my own analysis by looking at that. I would probably want to read whoever's graph this was. I'd want to read their analysis. There may have been other factors that I'm not considering here. Okay, that's the importance of kind of reading the whole report. Okay, but at least I get an idea of what their experiment did. Okay, and that's the purpose of a graph, is to quickly report what an experiment did. Everybody with me there? Right? But to do that, we got to make sure our graphs are in the right format. The right format is the axes are clearly labeled. Okay? The manipulated variable on the x, responding on the y. Then we also have to have a uniform scale that is reasonable. Okay? I wouldn't want to just go 0 and then 40. Okay? I want to make sure that my scale is big enough that my graph or my data takes up most of the graph. Right? Again, the nice thing about Google Sheets is it'll do that for you. Okay, back in the day when we had to do this by hand, you had to go, okay, my biggest number is this number, and I have this many lines on the graph, and I divide my biggest number by the number of lines, and then have to approximate how much to make each line worth. It was a pain in the neck. Okay, it's nice that technology can do that for us now. Right, so the scale will be set up so that our graph takes up as much of the graph area as possible. I would say that this guy wasted some space. Okay? In this graph, some space was wasted. Okay? He's got the graph going all the way up to 400 when its highest value is less than 200. Okay? I would say he should have probably made the y-axis scale a little bigger, right? So that 200 was at the top, right? And we could see a little bit more detail in there. I mean, I can still get the idea from his graph, but that would be something I would fix. So I'd say on this graph, there's 2 mistakes. Okay? You didn't have a title on it, and the scale for the y-axis wasn't great. Okay. Other than that, it's a pretty good graph. Okay, everybody with me there? All right. Now, this is obviously not a line graph either because it's not a linear trend, right? The points don't generally go one direction. They go up and then they plummet. And so it's showing us something a little bit different there. Okay, what I want you guys to do, and I'm going to walk you through this, okay, is we're going to open up Google Sheets and we're going to enter the data for this book thickness graph. So I'm doing an experiment where I look at several different books, okay, and I look at the relationship between the number of pages and the thickness of the book. Obviously, the more pages, the thicker the book will be, but that's what we're going to find out, okay? So we're going to graph this data. So I'm going to walk you through that, okay, just on the screen here. Okay, so when you open up Google Sheets, okay, so sorry, I'll show you kind of how this works right from the beginning here. All right, so you'll have your kind of browser open here, and if you click up here on the boxes, okay, your apps show up. Hopefully with yours, Google Sheets is on that first page of apps, right? So you're just going to click on that and open up Google Sheets. All right, when you do, you'll get a thing that asks you, do you want to make a new sheet? Like it'll say new spreadsheet, attendance. It's got some templates here. Obviously, you want to start with a blank sheet. All right, so you would click on the blank sheet. And when you do that, you get exactly as advertised, a blank untitled sheet. All right, so what we're going to do first is we're going to click up here in the title area, and we're going to call this like graphing practice or something like that. Okay, so you can, when you click up in here, all right, it'll allow you to change whatever you want that spreadsheet to be called. Okay, then we're going to enter the data. Now, a couple of things about entering data into Google Sheets that you need to be aware of. If you try and put numbers and letters in the same box, Google Sheets gets confused because it doesn't know whether you're graphing alphabetical stuff or numerical stuff, and it'll never graph it right. So your first row, whenever you're doing a graph in Google Sheets, will need to be your labels. Column A will be what's going to go on your x-axis, and column B will go on the y-axis. All right, so I'm going to use the first row to tell it the x-axis is going to be the number of sheets in the book, and the y-axis is going to be the thickness of the book. And I put the units in there as well, if that's appropriate. Obviously, number of sheets, the units are a number, okay? But for thickness, I'm measuring that in millimeters. Bless you. Okay, then I just want to enter my data. Okay, so I'll give you guys a couple minutes to just get the data entered in as I have here. Notice though, I'm not putting millimeters beside any of the numbers in the thickness column. I already put millimeters up here. If I put mm beside any of these numbers, look what happens. Okay, whoop, I didn't want to do that. If I put millimeters beside that number, do you see how it treats it differently? It doesn't put it over here with the other numbers because it doesn't know now if that was a number or whether it was something else. So it gets confused. So you don't want to put in any letters or you'll confuse Google Sheets. Okay, as soon as I take that away, it goes back over here with the other numbers. All right, I'll give you a couple minutes to get caught up with me there by entering all the numbers. All right, now we want to build our graph. So what we have to do is tell Google Sheets what information needs to go on the graph. We do that by simply clicking in the first box and dragging to highlight everything we've entered. All right, so click and drag so that all the boxes with stuff in it turn blue. Then we're going to go up to Insert. Okay, click on Insert, and if you scroll down about halfway, there's an option here for Chart. Okay, that's what we're going to click, and then it's going to give us a dialog box that asks us about the details, okay, of our graph that we're going to use. So we click on that, and Google Sheets always picks the wrong kind of graph. I have yet to have Google Sheets pick the right type of graph when I ask it to graph something. Okay, it's graphed it as a bar graph. I don't want a bar graph. I want what's called an XY scatter plot. Okay, so I'm going to click here where it says chart type. Okay, if I click on that, it gives me a whole bunch of options. I need to scroll down until I get to scatter. Okay, if I click on scatter, the bars will disappear and I'll get little points instead. Okay, now this graph is still not kind of where I want it because you can see I lost my grid lines. I don't have any vertical grid lines here, and this is a recent update to Google Sheets that we'll have to fix here. All right, so what we need to do here is we need to click, nope, not that one, not that one, shoot. It's in customize. Hang on here. We also want to check our data range here. Hang on, guys. Oh. Okay, so we're going to go to customize here, and we're going to change a couple of things. It's actually down in vertical or horizontal axis, I think is where we have. Okay, so we've got here this box. Oh, sorry, I'm going to back up here so you see what I'm doing. So I'm going to go to customize. Customize is where we add things like a proper title and labels and all that kind of stuff. Okay, so I'm going to go down to where it says horizontal axis, and I'm going to click on horizontal axis. Okay, and for some reason this box is checked. Okay, it never used to be checked as a default, but now Google Sheets made an update and it's checked. Okay, so what I'm going to do is uncheck that box, and you can see I get my grid lines back then. Okay, because it wasn't treating the numbers I had in the number of sheets as numbers. It was treating them as labels, which is not what I want. Okay, I want them to treat them as numbers. So by unclicking the treat labels as text box, I get a proper graph with grid lines. Okay, so now that my graph kind of looks right, now I want to fix a couple of things like the title. Okay, my labels are good. Okay, Google Sheets does a pretty good job of picking the right labels. I've got thickness in millimeters on the y-axis. I got number of sheets down here on the x. That's good. So I'm going to go up here to chart axis and titles. All right, and it says here that I'm changing my chart title, so I'm just going to click right here and change it to book thickness graph or something. Okay, so I give it a different title. Now it says book thickness graph up there. Okay, and if I wanted to, okay, if I needed to change anything on the axis, I would just click here. You can make a subtitle. You can change the horizontal axis title from number of sheets to something else, but obviously we want to keep it at number of sheets because that's what it is. Okay, and we can also change the vertical axis stuff there as well. All right, so now we have a title on there. We can close that one up. All right, if we look in series, there's a couple of things that we can do in there that we're going to have to do in there. So I clicked on series and it got the drop down here. Some of our options are the size of the points. Okay, for this graph, having big points is fine because we're not worried about accuracy. But when we get to other graphs and we're like plotting multiple series on one graph, we'll want those points to be smaller. Okay, you do that here on point size. You can make them really, really small. Okay, or you can make them stupid big. Okay, I don't know. I always kind of keep them around 2 points. And you can change the shape of them as well if you want to. You can make them stars or diamonds or whatever. Okay, I'm just going to leave them as circles for now. Okay, the most important thing we do in the series tab is add a best fit line. Okay, they call it a trend line, but it's a line of best fit. All right, so I'm going to check this box right here where it says trend line. And as soon as I do that, more options are going to come available for me. Right, so I'm going to click on trend line, and you can see then that I got a whole bunch of stuff underneath. Right, so it drew a line, and it's just because of the numbers I picked, it actually connected the dots only because they're perfectly in line with each other. A lot of the time when you do this, the dots won't be on the line. The line will just follow their trend, which is what a trend line is supposed to do. Right, so now that I've got that trend line, now I want to find out information about it. So I'm going to go down a little bit here to where it says label. Okay, right now it isn't labeling that line as anything. What I want it to show me is the equation for that line. So I click on use equation. Okay, and then it shows me this. Okay, 0.15 times x plus 5. All right, if you've taken math, this is the graphing equation. It is saying that y equals m times x plus b. Okay, so the slope of this line is 0.15. Okay, the y-intercept of this line is 5. I'll talk about what all that means here in just a minute once we have the graph built. Okay, so now I've got that graph built. I'm good. I'm done. I don't need to do anything else to it. Okay, you can fool around with legends and other things if you want to, but okay, for right now, this graph has everything on it that we need. All right, so I'm just going to copy it over into my Google Sheet here, or into my thing here. All right, so there it is. It's got a little more grid lines on it, but that's fine. Okay, so now we're going to look at some of the things we do with this graph once we have it built. Okay, so as I was saying, okay, this equation here is the graphing equation for this particular line. The graphing equation always sets up like this. Y equals m times x plus b, right? Y is the y value of any point on the line. Okay, so if I was looking at this point right here, okay, y would be over there, okay, whatever it was in our data. In our data, it was, yeah, 14 exactly, okay? And then x would be whatever its x value is, okay? So in our thing there, it was 60, yeah. Okay, so that's what we know right there, okay? M is the slope, okay? The slope of the line tells me essentially how steep the line is or how much it goes up as it goes over. Okay, you may have been taught this equation to calculate slope at some point in the past. Slope equals rise over run. Does that sound familiar to anybody? Okay, so if you have rise over run, basically what you're doing is going y2 minus y1 over x2 minus x1. The change in y divided by the change in x. Does that look familiar? Okay. Some of you may have learned that, some of you may not have. Okay, but slope basically tells us how much the line goes up versus how much it goes over. In other words, how steep it is. Okay, slope. B is the y-intercept. Okay, that tells me where the line crosses the y-axis. Okay, so for this line, it crosses at 5, which is telling me, at least for this graph, that a book with no pages would be how thick? 5 millimeters. In other words, that's how thick the cover of the book is. All right, something like that. Okay, the y-intercept a lot of times tells me about the beginning of the experiment, what was going on at time 0 or when the initial point. Okay, that's kind of what the y-intercept tells me. Okay. All right, now for the slope, okay, the slope again, like we said, is going to tell us kind of the rise over the run. Okay, it's y2 minus y1 over x2 minus x1. Why did I have x2 there twice? All right, I don't want to use this formula in Science 10, okay, because it only calculates slope. All right, y equals mx plus b not only will calculate slope for me, it'll calculate values beyond the graph or values that weren't points on the graph. And I'm going to show you how that works here in a minute. But if I want to calculate the slope of this line, okay, Google Sheets already did it for me. Okay? It's telling me that the slope of this line is 0.15 millimeters per sheet. Okay, so the slope of this line represents how thick one single sheet of the book is. Okay, how many millimeters per sheet? Everyone okay with that idea? All right. I want to manipulate for m. How would I do that? I want to solve for m. How do I move stuff around in that equation so I'm solving for m? Which one do I want to do first, the minus b or divide x? Minus b, right. Move what's not attached first. Remember we talked about that the other day? Okay, so I'm going to have y minus b, okay, equals m times x, and then I'm going to divide both sides by x. All right, so I'm looking at this. The slope is y minus b over x. Is that the same as this formula here that I just crossed out? Okay, y is the y value of this point. That would be like y2. Okay, b is y1. So I'm still going y2 minus y1, okay, over x. Well, here's x2, and x1 is 0. It's the same formula, okay? This whole rise over run thing that you may or may not have used is really just this formula here, okay? It's the graphing equation manipulated for m, right? Now, here's what the graphing equation can do for us. The graphing equation can allow us to calculate things that are not on the graph. For example, with this graph, I might give you a question like this, okay? How thick is a book with 525 pages? I don't have 525 pages on this graph, do I? This graph only goes up to 100 pages. So, number of, sorry, I should say sheets. I shouldn't say pages. I should say sheets. Okay. All right, so it's got 525 sheets. Is that value there, the 525, is that an x value or a y value according to this graph? Okay, so it's an x value. All right, now according to my graph here, okay, I already know what m and b are. I know that m is 0.15 and I know that b is 5. All right, I want to figure out how thick this book with 525 sheets is. So they gave me an x value and they want me to find y, because y is the thickness of the book. All right, so I just have to plug numbers into this equation and I can calculate using the data I gathered. I can extrapolate how thick a bigger book would be using this data. All right, so that's what I'm going to do. They gave me an x value, so I'm going to plug it in for x. And I'm going to calculate how thick a 525 sheet book would be. So I take 0.15, which we said is the thickness of one sheet, okay, times 525 sheets plus 5, which we said was the thickness of the cover. Okay, so we're adding the thickness of the cover plus the thickness due to 525 sheets, and that'll give me the thickness of the book. All right, everybody okay with that? Okay, so we would find out then that this book is 83.75 millimeters. That's a thick book. Okay, that's what? Yeah, 8.5 centimeters almost. Okay, it's a pretty thick book. That's War and Peace or something. Okay, pretty thick. Everyone follow me on that one? Okay, here's another one. I want you guys to try this one. Okay, I want you guys to calculate how many sheets are in a book that's 115 millimeters thick. All right, I'm going to give you a minute. You're using this equation here to calculate that. Okay, so for this one here, remembering that our equation is that y equals 0.15 times x plus 5, okay, what did they give me, a y or an x value? They gave me a y value. What are they asking me for? An x value. All right, so I've got to solve for x. So again, I'm going to subtract b over to this side. So I'm going to have y minus 5 over 0.15, right? I'm going to divide, and that'll leave me with x. So I subtracted the 5, then I divided the 0.15 over here. So that's going to leave me with x. So if I plug in all my numbers, okay, that's going to be 115 millimeters minus 5 millimeters divided by 0.15 millimeters per sheet. So 110 divided by 0.15. So this has 733 sheets, because you can't have 0.3 sheets. Okay, everybody all right with that? Okay, those are the types of calculations to be expected to do using the graphing equation. Nothing terribly difficult. Okay, you just have to manipulate it to solve for y or x. Okay. Okay. The nice thing about this, guys, using Google Sheets is Google Sheets calculates the slope for you. Right? Back when you had to do this by hand, you had to calculate the slope as well. And it was a different number for everybody, because everybody drew the line a little bit differently because you drew it freehand. Okay, and so everybody's line was a little different. It was really hard to mark on a test. Okay, I'd have to like draw a line I thought was perfect and then draw a line that I thought was a little too steep and one was a little too shallow and take any values in between those numbers. Okay, like it was a pain in the neck. Right? With Google Sheets, okay, it's much easier because it's going to do the calculating for us. Okay. All right, I want you guys to build this graph. The graph of diameter versus circumference. The experiment is that I'm choosing different diameters and then measuring the circumference of the circles. Okay. Before we build this graph, what should the slope of my trend line be for this? Pi. Exactly. Right? That's the relationship between all of those numbers, 3.14, blah, blah, blah. Okay, that should be the relationship there. That should be the slope of the line. It should be pi. Okay, but we'll find out here in a second when we build the graph. Okay, so same steps as before. Right, I'm just going to shrink it back down here. Okay, I'm going to highlight all of my information. I'm going to go to Insert, Chart. Okay, of course it picked the wrong stuff again. It also unselected this box for whatever reason. Okay, we need to use column A, okay, as labels in there. All right, and then we're going to obviously fix that this is not supposed to be a bar graph. Okay, so we're going to go down to Scatterplot again. Okay. And obviously it doesn't look very linear right now, but that's because it did this weird thing where it treated them as text, and we don't want that. So we're going to now go to Customize, right? And we're going to go to Horizontal Axis and uncheck this box. Okay, so I'm in Horizontal Axis, and I'm going to uncheck the Treat Labels as Text. Now it looks nice and linear, okay, like it should be. All right, now I can fill in the other stuff. So I'm going to go to, not chart style. I'm going to go to chart axis and titles, and I'm going to call it circle graph or something silly like that. Okay. Are you lost? Sorry, it sounds like I lost some people. Yeah, that's why I said uncheck that box. Yeah. Pardon me? Change to straight, like a diagonal line? Yeah, that's what we wanted. Yeah. Okay, like it should look like this, right? Yeah, that's what we want it to look like. Okay. All right. Now, guys, we also don't have, for some reason, it didn't put any labels on this graph. So we need to go to chart axis and titles again. Okay, or at least it didn't for me. I'm not sure why. Okay, and I'm going to go to horizontal axis title, and I'm just going to put in there diameter in meters. Okay, and then I'm going to do the vertical axis as well, but that's circumference, also in meters. Okay, so now that's all labeled. Now I've got a properly formatted graph. Then I want to go to series. Okay, I want to click on series because that's where I'm going to get my trend line. So I click on series here, and I click the box for trend line. And then I get all these other options down here. So I'm going to scroll down, okay, to the label and tell it that I want the equation for the line. I want y equals mx plus b for that line. All right, so there's what I've got. Okay, now, in theory here, guys, if this was theoretically perfect, okay, what should my y-intercept be if this was perfect? Yeah, it should be 0. Okay, it's not, but it should be. The reason it's not is because all of these numbers are rounded off. Okay, it's close to 0. It's 1.52 times 10 to the minus 5. Okay, that's 0.00015. Okay, it's essentially 0. Right, but because I rounded off some of those numbers, it didn't come out to exactly 0, and that's okay. Right. So now that I've got that graph, okay, I'm going to copy and paste it over, and we're going to answer some questions about it. Well, actually, for that one, we won't answer any questions because we know because of circles how it works. Okay? Everybody with me there? Now, guys, let's say at this point, I want to add in one more data point. Okay? What's the circumference of a circle with a diameter of 0? 0. All right, I want to add that in. Here's how I do it. Okay, I can actually make changes and they'll reflect on this graph as I do it. All right, so I'm just going to go back into my data here and I'm going to insert a row. Okay, and then I'm going to put in 0 and 0. Okay, now I actually get a nice y-axis. Okay, I didn't have a really good one before, and probably you didn't either. Right, and it doesn't change it changes my equation slightly. Okay, ever so slightly, but it changes it a little tiny bit. Right, so if you ever find that, oh shoot, I forgot something, you don't have to scrap the whole graph. Just go in and add the data. The graph will update automatically for you. Okay, which is way better than having to do it by hand, where you did have to scrap the whole graph and start over again. Okay, so be thankful you live when you do, and not back in the day of pencil and paper graphing. Okay. All right, I want you guys now to try this one. Oh. Okay, so you go into in customize, series, trend line. See the box ticked here? Click on that and then click down here on label, use equation. Okay. All right, I want you guys to make this rubber band graph. Yes.